Hi everybody, welcome to our channel of Sciences and Mathematics. Today we are going to deal with a topic in chemistry. Of course, it's a branch of organic chemistry, and still we are going to deal with the naming of a particular class of organic compounds, and that is the amines. So the amines are a group of organic compounds that consist of nitrogen in their functional group. So we are going to look at different examples of amines and how they are being named. So without further ado, thank you and welcome. So as we have said, today we are going to look at different class of organic compounds, and that specifically will be entailing the naming of this class of organic compounds. And as we have said, we shall look at the different examples of amines and how they are being named or given their IUPAC names. So to start with, as we were dealing with other class of organic compounds, there are some specific rules that we said that apply across all the organic class of organic compounds that we said, but majority of them, like the alkenes, alkynes, amides, carboxylic groups, aldehydes and ketones, you find that they derive their names from the parent alkane groups. So for amines, we shall try to see which particular rules apply in this case, and how different rules as well can be applied in as far as the naming is concerned. So for that case, we shall start for amines. We shall just give a functional group to represent the amines. And try to see how this particular amines appear. So for that case, the functional group for amines is represented by this particular structure. So from there, then we can find that we can form a different or a range or a class or just a range of compounds from this particular set of functional group that we are defining as amines. So in that case, we're going to look at the same procedure that you have employed in naming other organic compounds. So we shall look at the parent name, the suffix, the prefix, etc. Now, in the case of amines, for the suffix, we use the name amine. This is the ending of this particular amines. And we treat alkyl groups attached to the nitrogen as substituents. So there are other groups that will be attached to the nitrogen, so we shall treat them as substituents, but we shall look at some of the other rules that apply apart from this. And we also use the term di and tri to denote single or double substitution of the same groups. So in that case, amines also display the first, second, and third degree of substitution that we are calling the primary, secondary, and tertiary amines. So for that case, we shall just try to look at some of the examples. So I will put this as nitrogen for the amine group. So I'm going to use that one to demonstrate that particular example for primary, secondary, and tertiary amines, as if for the first degree, second, and third substitution. So we have this is 3H, hydrogen, CH3. These are methyl groups at those particular points, and then we have hydrogen, a methyl group, and then we have got 3 methyl groups at this particular point. So we can see that from the first one, there's only one substituted hydrogen for the methyl group, this one. So for this particular kind of amines, they contain two hydrogens on the N atom as we have seen. So there are two hydrogens. This is hydrogen number 1, 2. Now the second class, we have two substitutions for the amine groups. This is the first one, and this is the second one, and a single hydrogen. So for that case, we have one hydrogen on the nitrogen atom, attached to the nitrogen atom. And then for the third one, we have 1, 2, 3. So these are, okay, this one is 3. We have 3 methyl groups attached to the nitrogen. So this one we have 0 hydrogens. This one stands for 0 and not oxygen. So it's 0 hydrogens on the nitrogen atom. So this one reserves specific names, as we have said. This is a 1 substitution for methyl, 2 substitutions, 3 substitutions. In that case, this one we call it the primary amine. Primary amine, secondary amine, and this is known as the tertiary amine. So in other literature or some other, of course, which are trying to illustrate this, you can find that it has been given for this one as first degree, this one as the second degree, and this one as the third degree. So for that case, whenever we come across those terms, always remember that they are just being used in reference to this particular degree of substitution for the nitrogen group. So that is for the amines. So in this case, we have said that the suffix for amines is amine, and then the prefix is amino. So let's see that one. The prefix used for this class of organic compounds is amino, and we have said that the suffix is amine. And then the substitution on the nitrogen, the ones that we have indicated using the first, second, and third degree. Of course, there might be any other R groups, whereby R stands for radicals. There might be other radicals that are substituting instead of the methyl that we are using there. So for that case, substitutions on the nitrogen are denoted by the letter N. So for amines, substitutions on the nitrogen are denoted by the letter N. So also remember that one. Whenever we come across N, that we will remember that that is a substitution in that particular case. So also in this particular class of organic compounds, we also have cyclic and acyclic, or in that order, chains, and then we have rings. So in this case, we are going to look at a few examples which pertains to the chains, and then we shall look at maybe 1 or 2 examples for rings. So we shall look at one of the examples of maybe a simple amine, and from there it will give us a guidance on how to name the preceding or the subsequent ones as we go ahead. So let's look at one of the examples of amines, and then we shall look and see whether it's a primary, secondary, or a tertiary amine. But what we're interested for as at now is giving it an IUPAC name or a common name if it's generally acceptable. It's the one to be used. So for that case, we have an example of an amine. This is H2, H2, and then we have H3. So in this case, if we count the number of the carbons that are attached to the, of course this is a functional group, we count the number of the carbons in this particular compound, we will get it is carbon number 1, 2, 3. So from the alkane series, this one will have the name propyl for the substituent. So that is the prefix for this particular compound. So since it does not have another substance from there, so that's a propyl, and then we shall give it a suffix, which we say for amines, it is amine. So the name for this particular compound or amine is propyl amine. So 1, 2, 3, propene from alkanes, propyl amine. So we shall look at another example. Oh, sorry for that. There's something that I wanted us to try and figure out before we move ahead. So still I will just repeat, just draw a Lewis structure. For that case, I can just see that this hydrogen is. Okay, we mentioned about the first, second, and third degree substitution. So in this case, we have nitrogen attached to a carbon, but has got 2 hydrogen groups, and we called this one a first degree substitution of the primary amine. So for the sake of us remembering in that order, it's good for us to mention, so that as we go ahead, we are able to name it in case we are required to. So that's a primary amine. So let's look at another case whereby we have nitrogen and then H2, CH3, H3, H2, H2. So if we identify this one as well, you find that this particular nitrogen has been substituted by R groups. These are radicals, and from our alkane series we can identify these particular radical groups as containing, we have actually a range of 3 radical groups which are surrounding the nitrogen. This is the first one, this is the second one, and this is the third one. So if we try to look at their particular structure, you'll note that they are all the same. Actually, this is a 2-carbon member, which is known as ethyl. So that is an ethyl group, or ethane from the primary class of organic compounds. That's from the alkane series, that is an ethane. It's an ethyl now when it has been substituted. So in that case, we said that for amines as well, we can use the prefixes di, tri, tetra, etc. to denote the number of times in which a substituent has been repeated. So in this case, it is 3 times. We are likely to use this particular notation, designation for that particular compound. So secondly, we can identify from the primary, secondary, and tertiary amines that we mentioned. Now this one, there is no another hydrogen in this particular compound attached to the nitrogen group that we have said. So basically this will belong to the tertiary group of amines, or a 3rd degree, as we said, amine. So in this case, we shall go ahead and name them. We have identified and said that we have an R group that repeats itself 3 times, so it's a tri. So the name for this particular compound will be, we'll start with the prefix. So whenever we are trying to name amines, for the second and third substitution of the secondary and tertiary amines with the different R groups, the parent amine is the one with the largest R group. So this one implies that suppose we had maybe a propyl group at this particular point, then we shall consider that this particular nitrogen, the parent name will be derived from the substitution that has got the largest number of carbons of the radicals groups which are attached to the nitrogen. So in that case, whenever they are the same as you have said, we can just use that as ditri etc. So we have identified it as a third or a tertiary alcohol, so a tertiary amine. So let's name it. So it is tri, and then the name of the substance ethyl, triethyl, and then the suffix will be amine, triethyl amine. Now we can as well look at, maybe we have looked at the primary and secondary, primary and tertiary amines. Let's look at one example of the remaining one, that is a secondary amine, and also try to see how they are being named. So we shall have an example here. So for the secondary, or the second degree substitution, we shall have nitrogen with a single hydrogen. It's attached to a hydrogen there, so we shall have a formula like that. Now this is a methyl group, so H2, so H2, H2, H3. So the name of that compound, as we said, that whenever we have two substitutions from the nitrogen, we always consider the radical with the largest number of carbon atoms as the parent. We consider that one as the parent amine. So in this case, this is a 3-member 1, 2, 3 from the alkane series. So its name will be, the parent name will be propane. So propane, propane. You can reserve that one for that. And then this is the nitrogen. We said that whenever there is a substitution for these different groups, whenever there is a substitution and we want to mention that one, this is the amine group, we start by indicating the name, the letter N for amines. So we shall have N-methyl, propan, amine. Now for other groups, like we said, like the alkanes, we use numerical figures here. That is 1, 2, 3, 4. There's the number of carbons, or the point at which there's a substitution, or there's a methyl, or there's a substituent attached to that particular carbon. So for this particular case, we shall look at some cases whereby we're going to use this, but there's a rule that indicates that we use N to make the name of those particular class of organic compounds, the way we have just demonstrated. So for that case, we shall look at a cyclic member of this particular class of organic compounds, and also try to see how it is being named as well. So let's look at this compound. It's a cyclic one. So there's a substitution at that point, and another one at this particular point on our left, that's CH3. So from this case, we looked at the functional group, different functional groups that we were trying to look at. And then if we look at this, that one, there's a class of organic compound that we're going to discuss. Of course, it's under the class of ethers. There's a class of organic compounds that are known as ethers. We haven't discussed them, but of course, I'm going to put a link of the video of those particular class of organic compounds in this video in the description box, so that we can have to remind ourselves about the nomenclature of ethers. So from that case, we are dealing with amines, and this is the functional group at this particular point. So the counting starts from this. We count carbon number 1, 2, 3. I believe that we are conversant with the cyclic members. In this case, of course, we have another one which is aromatic compounds, which of course basically is benzene, and it is other substitutions or substituents. So in that case, for this, that's benzene as a member. We have others like anthracene, but for this case, we shall just look at the cyclic compound that is single bonded. And then there's a substitution at that particular point. I mentioned the term ether, which is another class of organic compound, because in the name of this compound, we are going to find the name of a substituent, which is having similar properties, or maybe the same as the ethers that we are talking about. So that particular substituent is known as, that's a single carbon, it's known as methoxide. So we shall put the number at which, or at its position, so it is 3-methoxide. This 3-methoxide. This compound is cyclic, so we shall put the name cyclo. And then that particular ring is an alkane. It's a 6-member. It's known as hexane, so we shall have hexane. And then hexanamine. You can decide to put this one or just write hexanamine. So for that case, we've just indicated. So it is 3-methoxide, 1, 2, 3, substitution at that point. Cyclo, because it is cyclic. Hexane, 6-member, and then amine. That's at this particular point. So since that's a cyclic one, even if it's attached at this point, we shall start counting from that. So it is just the same. So lastly, let's look at another example that maybe has got a somehow unique substituent, so that we can be able to see also how that kind of a compound can be named. So let's look at this. So 4 carbons, H2, H. So there's a H here, and then there's a N, CH2, CH3, CH2, CH3. So from that case, we can look at this particular amine, and as we said, the parent name is derived from the substituent that has got the largest number of carbons. So for this case, we shall have this one. These are 2 carbons, 4 carbons. So it shall come from this particular point. And the second point to note is that there's a double bond here. So this one falls under the class of alkenes, and then we can see that the substituents of these particular compounds at this point are the same. So the radical here just the same as the radical here, but the one that we have chosen as a parent name is a different radical, which I've indicated by R prime. So for that case, that is the parent name. So in naming this, as we have chosen the parent, the part of the molecule that is a parent name, the rest are treated as substituents. So the parent name, we have identified it as a butene, since it has a double bonds, and then these ones are known as ethyl groups. For substituents of this particular kind, these are RR, the same ethyl. So we shall have diethyl in the name of that particular compound, and then we shall have to indicate the position of this double bond. So let's try to figure it out. So the name will start by the letters, as we said, N. N means there's a substitution of the ethyl group here, and another N, there's another substitution at that particular point still. Diethyl, and then that is a 4-member carbon. But so this one we are going to look at the substitution of the double bond and try to see at what point it is. So it is but 3 in, and then we see the position of the amine groups in that particular member of the or derivative of the alkane series. The amine is at position 2, and then the suffix is amine. So NN diethyl but 3 in 2 amine. So in that case, we are also going to look at the different classes of amines and try to compare, of course, which format we are supposed to use for naming that. But as at now, those are the specific rules that apply in as far as naming of amines are concerned. And we shall look at other examples as we progress in our study, of course, of the reactions of amines and how some of the maybe how it can be produced, and other topics which entails this class of organic compounds. So for that case, I thank you very much for having stayed with me in this particular kind of lesson. So I'd like to request for those of us who have not subscribed yet to our channel, kindly subscribe so that you can be getting updates on the new contents that we upload. Hit that notification bell so that you can be getting as well notified in case we have anything new that we have to discuss, and also contribute in our comment section so that we can be able to improve our content and assist one another. So for that case, I thank you very much and I wish you the best. Bye. God bless you.